Today we discuss a new chapter, ellipse. Like parabola, it has a definite definition, which is, suppose a plane has a fixed point and a fixed straight line, like parabola. Now, if a point P moves in the plane in such a way that in its path, distance of the point P and S, that is SP, it will be E into PM. M is the foot of perpendicular from P to the fixed straight line L, and E is a particular constant less than 1. If the point P moves all along in such a way that SP is equal to E into PM, then the path traced by the moving point is called an ellipse. It is like parabola. In parabola, E was 1 in parabola. Here E is a particular constant which is less than 1. For a ellipse, its shape is like that. This is x-axis, this is y-axis. For a particular selection of x-axis and y-axis, the equation of the ellipse will be x square by s square plus y square by b square is equal to 1. So A, it is actually from this point, it is A is from origin to the point A. OA is A, OB is B. This one is called major axis of the ellipse. Major axis of the ellipse, and its length is 2A. Its length is 2A. This length, minor axis, B dash is minor axis, its length is 2B. O is center of the parabola, of the ellipse, sorry. So, in fact, there are two types of ellipse. One is that here, this equation here, A is greater than B. Other is, this is x-axis, this is y-axis, this is center O, this is major axis, and this is minor axis in that case, and its equation almost same, x square by a square plus y square by b square is equal to 1. Here A is less than B, that is B is greater than A. There is a relation between A, B, and that E. SP by PM is equal to E. That is known as eccentricity of the conic ellipse. And eccentricity of the conic is That is, a relation between A, B and E is B square. For this case, when A is greater than B, it is B square is equal to A square into 1 minus E square. For that ellipse, that is when B is greater than A, the relation between A, B and E is A square is equal to B square into 1 minus E square. For this and that, these two types of ellipse, here you see A and B will be interchanged. A and B will be interchanged and X and Y will be interchanged. For both the cases, center is at the point origin 0, 0. Major axis, this is 2A, its major axis is 2B. And minor axis, its minor axis is 2B, its minor axis is 2A. A and B are interchanged always. Vertices. For this case, vertices is this and that. Its coordinate is A, 0 minus A, 0. For that case, it is 0, B and it is 0, minus B. Eccentricity E for this case can be derived from here. It is actually equal to E is equal to not square, E is equal to root over of 1 minus B square by A square. E is equal to 1 minus B square by A square. For that case, E is equal to root over of 1 minus A square by B square. You see, always A and B are interchanged for this and that. Focus. Focus of any ellipse must lie on major axis. This case, it is here. For this case, it is on major axis that is there. Normally, it is denoted, normally, ellipse has two foci, and S and S dash. Its focus is S is equal to AE, 0. This is minus AE, 0. E is defined by that, and for that case, its focus S is equal to, it is on y-axis, so 0, BE. Other is here, S dash, it is 0 minus BE. This is focus. The next, length of latus rectum. Latus rectum, as I told you in case of parabola, it is a straight line passing through focus and perpendicular to the major axis and terminated at the conic L dash. This is length of major axis L dash. Here also it passes through focus perpendicular to the major axis and terminated at the on conic at the point L and L dash. The length L dash, that is length of latus rectum, for this case it is equal to 2 B square by A, and for this case it is 2 A square by B. Always you see, for these two cases, A and B interchanged. A square by 2 A square by B, not B square. Next, equation of directrix. Equation of directrix is this. It is outside the ellipse and perpendicular to the major axis. For that case, it is like that. outside the ellipse and perpendicular to the major axis. Like focus, ellipse has two directrices. One is along that and other is along that. Corresponding to the focus S, the corresponding directrix is this, and corresponding to focus S dash, directrix is that. Its equation is x is equal to, one is a by e and other is x is equal to minus a by e. This is negative side, so it is actually plus minus a by e. You see, as e is less than 1, so a by e, it is greater than a. Greater than a means this is a, it is outside, that's why it is outside. And for that case, it is equation of directrix is this, and along that, its equation is y is equal to plus minus b by e. Endpoints of latus rectum L. It is an endpoint of latus rectum. Its x coordinate must be x coordinate of S, that is AE, and length is y coordinate is this half of the latus rectum, so that L, it is nothing but coordinate of L is AE b square by A. For this case, L dash, lower endpoint, it is AE minus b square by A. For that one, this point is minus AE and b square by A, and this end is minus AE minus b square by A. Similarly, for that, L is equal to, actually its x coordinate is that of S, that which is 0. So 0 comma height is that, and height is S, this is 2 square by B, length this one is, it is endpoints is S square by B. Oh sorry, not L is actually, this is L. So its x coordinate is that of this one. So it is simply a square by B, comma, and y coordinate is, its y coordinate is BE, that one. So L, for L dash, it is minus B, and equation of auxiliary circle. Auxiliary circle means, it is a new concept here. For any ellipse, if a circle is drawn whose diameter is the major axis of the ellipse, that is, it is passing through A and A dash, center is at O, then that circle is called auxiliary circle of that. For this case, equation of auxiliary circle is x square plus y square is equal to a square. Center is this, so radius is A, and center is 0, 0, so it is that. For that case, it is the circle passing through whose center is at origin, center of the ellipse, that is origin, and radius is this one, that is B. So it is x square plus y square is equal to b square. parametric representation of an ellipse. For both the cases, if we put x is equal to a cos theta, y is equal to b sin theta, this x and y will satisfy this equation. So, coordinate x and y can be expressed in terms of single variable theta. That's why this is called parametric representation of the ellipse. And just now I told you that this will satisfy this equation. For this case also, same equation, same parametric representation is x is equal to a cos theta and y is equal to b sin theta. Okay, now let us take few problems. One thing I must mention that for ellipse, problems are actually simple, very simple. Only thing you have to keep in mind all the formula just now I told you. Formula means equation, focus, relation between A, B and E, then length of lattice rectum, then distance between focus and lattice rectum, distance between focus and vertex, distance between focus and directrix, and all these things. If you can remember, most of the problems given for competitive exam can be solved easily and quickly. What I told you, suppose this is a ellipse. This is 2a, this is 2b. So it is equation is x by x square by a square plus y square by b square is equal to 1, and a is greater than b. It is focus is s, ae, comma 0. Equation of directrix is x is equal to a by e. Length of lattice rectum is that L dash. So distance between focus and corresponding equation of directrix is a by e minus ae. I have mentioned, but simply distance between s and equation of directrix is this. Distance between vertex to equation of directrix, it is equal to a comma 0. This is a by e, so it is a by e comma a. All these formula, if you can remember, most of the problems, at least 90% of the problems given here for competitive exam can be solved easily. Now let us see the type of problems. First problem. The distance between focus and corresponding directrix of an ellipse is 16. The distance between a focus and its corresponding directrix of an ellipse is 16. Its eccentricity is 3 by 5. Then length of lattice rectum of the ellipse is options 128 by 3, 128 by 5, 288 by 15 and 230 by 9. So here the problem is for a ellipse, distance between focus and corresponding directrix is given as 16. That is this is focus, this is directrix, x is equal to a by e. You can use this and that also. Distance between this and that, it is given as 16. So with the standard formula, we are given that distance between focus and that is, just now I told you that a by e minus a e. This is a by e minus a e. Here e is given as 3 by 5, that it is equal to 16, that is a into 1 by e, that is 5 by 3 minus 3 by 5, it is equal to 16. So a into 25 minus 9 divided by 15 is equal to 16. And a is equal to, this is actually 25 to 15, so it is 16. So a is equal to 15. We obtain a. E is given already, and we have to find the length of lattice rectum. We know that length of lattice rectum LL dash is equal to 2b square by a. A is already known, and we have to find b. From the relation a, b, and e, we can obtain very easily. B square is equal to a square into 1 minus e square. That is, b square is equal to a square, means it is 15 into 15 into 1 minus e square is your 9 by 25. So that it is equal to 15 square into 16 by 25. So that it is 5 can be cancelled from there. So 5 can be cancelled. So 5 into 9 into 16 divided by 25 can be cancelled from there. 25 into 3, this is 5 into 5. So 5 cancels. Actually, this is divided by that. This is equal to, okay, I think calculation is all right. So it is equal to 144. B square is equal to 144. So answer is 2 into 144 divided by a. A means how much? A is your 15. So it is 288 by 15. Answer is C. So you see, just by simple application of formula, the problem can be solved. So our next problem. The equation of an ellipse having vertices plus minus 5, 0 and focus means plural foci at plus minus 4, 0. This is vertices, this is focus of an ellipse. Then its equation is so many options, 4 options are there. 25x square plus 9y square is equal to 225. Nine x square plus 25y square is equal to 225. Then 7x square plus 9y square, 9x square plus 7y square is equal to 63. Now, in that problem, two vertices are given and their focus are given this. Now, we know that for a standard equation of ellipse, its focus will lie on major axis. So clearly major axis is the x-axis. So its shape is of that type. A, it is 5, 0. This is minus 5, 0. Focus is S 4, 0. That focus is minus 4, 0 from there. So we have to find, to get equation of ellipse, it is of the type x square by a square plus y square by b square is equal to 1. We have to find a and b. A actually given as, this is your A, this is 2A, major length of major axis is 10, A is your 5, so A we get A is equal to 5. Now we have to obtain B. For that purpose, formula is B square is equal to A square into 1 minus E square. So we have to find B square, and before that we have to obtain value of E. E is equal to root over 1 minus B square by A square. Just I mentioned the formula. Root over that. Oh, sorry. Just 1 minute. Just 1 minute. So actually, focus, coordinate of focus is AE, 0. So clearly AE is equal to 4. A is your 5. So E is equal to 4 by 5. A is equal to 5. So B square can be written as A square means 25. 1 minus 16 by 25. So that it is equal to 25 into 25 minus 16, that is 9 by 25. 9. So that B square is equal to 9. So equation become x square by S square 25 plus y square by 9 is equal to 1. So multiplying both sides by 25 into 9, that is 225, 9x square plus 25y square is equal to 225. Second option is correct. Next problem. Oh, sorry. That problem was given in the West Bengal Joint Entrance. In the year 2008. Our next problem. The eccentricity of a curve represented by x is equal to 3 into cos t plus sin t, and y is equal to 4 into cos t minus sin t is. Options: root 7 by 4, root 7 by 2, 8 by 11 and 7 by 9. These are the options. And that problem was given in the year West Bengal Joint Entrance 2007. So here one parametric representation of an ellipse is given. The x coordinate is x is equal to 3 into cos t plus sin t, not in standard form, and y is equal to 4 into this minus that, cos t minus sin t. So we have to find its eccentricity. That means we have to find first of all, we have to find the equation of the ellipse in a Cartesian form, like x square by a square plus y square by b square is equal to 1. Then, knowing a and b, eccentricity can be obtained. For that purpose, we get cos t plus sin t is equal to x by 3. From there, cos t minus sin t is equal to y by 4. Actually, we have to eliminate the parameter t. Many ways are there. By adding, you get cos t. By subtracting, you get sin t. Then square and add, you will get answer. In this case, from the shape of the sin t and cos t, etc., by squaring and adding, we get the desired result. How much? The x square by 9 plus y square by 16, this square plus that square is equal to cos t plus sin t whole square plus cos t minus sin t whole square is equal to this cos square t plus sin square t is 1 plus 2 sin t cos t plus whole square of that cos square t plus sin square t is another 1 is minus plus 1 minus 2 cos t and sin t. So now you see they cancels, it is equal to 2. So that equation become x square by 18, here is 2, x square by 18 plus y square by 32 is equal to 1. So this is the equation of a ellipse, and in that case b square is greater than a square. So we have to find now its eccentricity. In that case, eccentricity is equal to a square is equal to b square into 1 minus e square. That is, a square means 18 is equal to 32 into 1 minus e square. Now e square can be obtained very easily. 1 minus e square is equal to 18 by 32, that is 9 by 16. That is, e square is equal to 1 minus 9 by 16, that is 7 by 16. E is equal to root 7 by 4. So our first option is correct. And actually formula was E is equal to root over of 1 minus a square by b square. Using that one, very easily you can obtain that without any lot of this 3 or 4 lines is unnecessary. The next problem. A circle passing through two focus of x square by 16 plus y square by 9 is equal to 1. This is an ellipse. A circle passing through its two foci. If its center is at the end of a minor axis, radius of the circle is. Its equation is like that. This is a focus, this is another focus, S dashed. A circle passes through these 2 points, S and S dashed, and center is at the end point of the minor axis. So circle is like that. So it is center. Coordinate of B is 0, B. B is your 3. It is 4 square, 3 square. So it is 0, 3. Center of the circle is at 0, 3. And first find the focus of the ellipse. This is greater than that. So E is equal to root over 1 minus b square by a square, 9 by 16. It is equal to 16, that is root 7 divided by 4. E. Then S will be coordinate of S. It is equal to AE. A is 4. That is, it is equal to 4 into E. Root 7 by 4 into 4. So it is root 7, 0. So radius is that. So actually radius square, r square, is equal to, it is root 7 whole square, root 7 minus 0 whole square, plus it is 0 minus 3 whole square, that is 7 plus 9. Radius is 4. Oh, options, I have forgotten to give you the options. One of the options is 4. Its options are actually 7 by 2, root 7 by 2, 4, and 7 by root 2. So option is 4. Okay. Today is up to this. Next day we'll take few more problems on ellipse. So I request you to share it, like it first, then share it and subscribe the channel. Thank you.